Lesson 5, which is our 4th lesson, is all about angles. Angles are formed by two rays with a common endpoint, and our endpoint is called the vertex. That's where these two rays combine. The rays are called the sides, and we, just like with a plane, we use 3 letters to name an angle. The difference is in a plane, order didn't matter. It could be plane ABC, it could be BCA, it didn't matter. Order matters with angles. And we can use a single letter if there's only one angle that we're looking at. If there's more than one angle, we have to use all 3 letters. So let's look at the types of angles now. The 3 basic ones, when it is less than 90, is called an acute angle, less than 90 degrees. More than 90, that's obtuse. When it's exactly 90, we call it a right angle. And this last one's a little tricky, but if it's a flat line, it's a straight line, and we call that a straight angle. This one, the straight angle, is worth exactly 180 degrees. So with an example here, example 1, name the vertex. Where is the middle of that angle? Where do the rays touch? Well, point K. So we can just write K. The sides, all right, the sides. We always name them going from the vertex outward. So when I name a side, I need 2 letters. KJ is one of them, and KL is the other. It's important that we go from vertex out. And then there's 3 ways to name this. I need to just go in order. So JKL, just like I'm tracing this, would be fine. That little symbol there, that little L that's squeezed, that's the notation for angle. So this is angle JKL. I can also go backwards, angle LKJ. And the third way we can name this angle is just by its vertex, because there's only one angle we're talking about. This can just be angle K. And then lastly, classify, is this obtuse, acute, right, straight? It's more than 90 degrees, so it's obtuse. Example 2 is exactly the same as example 1, so I'm going to go quick. Name the vertex. Where does it meet? S. The sides are SR and ST. I can do angle RST. I can do angle TSR, or I can simply do angle, not T, S, because that's the vertex. There's only one. And this box here tells me that this is 90 degrees. The box means 90. So it's a right angle. All right. Now let's talk about congruent parts. Remember, congruent just means the same. So if the measure of angle A, is equal to the measure of angle B, which is what I have here, 75 and 75, then we can write that as angle A is congruent to angle B. Okay, remember congruent? Same. So now more vocabulary. An angle bisector is the same as a segment bisector. To bisect is to cut in half. So an angle bisector just cuts an angle in half. A ray that divides an angle into 2 congruent halves or parts. And in the picture to the right, BD, ray BD, is the angle bisector. So I can say that angle ABD, that's this one here, A to B to D, is going to be congruent to angle DBC, and that is this one here. And I can see that in the diagram because this little arc tells me that this is congruent to that. That is the notation to show you, hey, this is the same as that because that arc is there. Perpendicular lines, two lines that intersect or cross at a right angle. And the symbol for perpendicular is like an upside down T. So in the diagram to the right, I could say that line M, and remember, if I name a line by just one letter, I gotta use that fancy script. Line M is perpendicular to line L, and I don't know how you write a fancy L, so there we go. Okay. And our last vocab word, a perpendicular bisector. So now we're being perpendicular, so I have a right angle. And bisected cuts in half, combining the two. So a line, segment, or ray perpendicular to a segment at its middle or its midpoint. In this picture to the right, line LM is the perpendicular bisector to line PQ. And how do I know which line is which? Because, well, they both make the box, so they're both being right angles. I can see that these tick marks here are telling me that this half is equal to that half. So this line is doing the cutting in half of this line. So LM is the bisector to PQ. And I have a lot of different ways I can do this. Another name for angle CBF, well, CBF is this one here, CBF. Another way to name that would be to go backwards, FBC. Angle FBC. Name the sides of EBD. EBD is this one. Well, the sides, I'm going to start inside. On the vertex, I'm going to go out. BD is one, and then BE is the other. Classify angle ABC. Well, where's that at? A to B to C. Well, that's a straight line, so that's a straight angle. Example of an obtuse angle. So any angle that is over 90 degrees, there's so many to choose from. This one right here pops out to me, EBD. So I'll go angle EBD. All right. Name two congruent angles. Well, I'm just looking for two angles that are the same, and this arc here matches with this arc here. So those are going to be my two easiest to find congruent angles. I will say angle EBA and angle CBF. Now there's other ones in there that you could make congruent. These ones just jump out to me. It gave me the little arcs, so I don't have to think too much harder about that. And then name the perpendicular bisector. So I have to find the tick marks first so I can see what thing is being cut in half. That's here and here. So ABC is the line that's being cutting in half. Let's find the box. And what is the box attached to? This ray. So ray BD is the one doing the bisecting. All right. Now I want to stop here and take a look at this diagram right here outside of the question. If you remember from the last page, it said you can use 3 letters to name an angle, or 1 letter if there's only one angle. There's tons of angles here, okay? So you can't say angle B. You can be talking about this angle, EBA, And you could say like, well, the vertex is B, I can just call it angle B, right? The other page said I can do that, but you can't, because B, the vertex, belongs to so many more angles. There's EBA, sure, but there's also ABD. There's DBF, there's CBF, there's EBD, there's CBA. There's so many angles here. So if you simply just say, hey, I'm talking about angle B, that doesn't narrow it down. In a situation like this, you have to give me the 3 letters. Name the vertex of angle 2. Well, angle 2 is this one here. Where's the vertex or the middle? T. Name the sides of angle 4. 4 is this one. And remember, sides we have to go vertex out. So TW and TZ. Another name for angle 3. Okay. Now, this is another time I can't just say T is the vertex, it's angle T, because there's so many T's. Let's go with UTT. Okay. Another name for angle 1. YTX. Angle YTX. You can do XTY, doesn't matter. Let's do some classifying. YTW. Y to T to W. Right? YTW, where is that? YTW. Well, that box there tells me that it's 90, so it's a right. Let's look at YTU. Okay. Well, that's definitely more than 90. I can't even do it with my fingers, so that's a 2's. XTU. X to TTU. That's this one here. And that is the cute, because that's less than 90. And last but not least, WXT, or sorry, WTX. Straight line, straight angle. Okay. What are the 2 perpendicular lines? Well, easy to find. The box is going to attach to both of them. The box is attached to this one. It also attaches itself to that one. So the 2 perpendicular lines are WX and YZ. Remember, there's so many more names you could choose to do that. This is just one example of how you can name both those lines. And what is the angle bisector? So where are the arcs? One here, one here. The thing that it is sharing is that line. So TU is the angle bisector. Okay, the angle addition postulate. This is little angle plus little angle equals big angle. So, what I mean by that is this angle here, ABD, this part, plus this other part. If I put both of those angles together, it's going to equal the whole thing. So we write that as angle ABD plus angle DBC equals the whole angle ABC. And we can see that each one, we can color code that. And highlighting makes geometry so much easier. So hopefully we can get into good practice of using that. So this is the green plus the blue equals the purple, pink, whatever you want to call that. So here are some problems. Measure ABD is 48 and DBC is 78. How much is ABC? Okay, well, small piece plus small piece equals the whole thing. 48 plus 78 equals 126. And that's the answer. Right. Number 2 says DBC is 74 and ABC, that's the whole thing, is 119. How much am I missing? Okay, well, if these two pieces together are supposed to make 119, let's take 119, take away what I have, and then that will be my other answer. That's 19 plus 26, which is 45, I think. And that's done. All right, I like to highlight these ones because I really do think it makes it a lot easier to understand. If PQR is the whole thing, find each measure. Okay. So PQS is here, PQS is this inside one here. And this one, SQR, is this one here, it's the other inside piece. So here I have blue plus purple equals green. This plus this is the whole thing. So I'm gonna take these two quantities that it gave me, and I'm gonna add them together, and I'm gonna set it equal to this, which is what the problem told me was the whole thing. So let's just combine our x's right now. 13x plus 10 more x is 23x. Plus 4 minus 1 is still plus 3. And all of this together is the 141. Okay, so now we have to solve for x. Subtract 3. 23x equals 138. And if we divide by that 23, we get x all alone. X equals 6. Right? Yeah. Okay, so x is 6. Well, that answers one of it. I need to go back for the other one. PQS was this blue angle that I highlighted in blue. That was 13 times x, and we just figured out x was 6 plus 4. 13 times 6 is 168. No, 178. 178 plus 4 is 82. Not having anyone here to fact check me. Okay, the other one. 10 times 6 minus 1. This one's easier to do in the head. That's 59. Okay, so here's our answers, and we can check now to see if we did it right, because we know that the blue plus the red should equal the green. Let's add these two together and see if it equals the green. 2 to make 1, carry the 1, that's going to be 13, 14, is 141 what it should be? Yep, okay. So we can check our answer. Alright. Same deal, if DEF is this, that's the whole thing. Okay, DEF is the whole thing. DEG is this half of it. And that one is 23. Okay, find x and each measure. All right. So this one, it gave me the whole thing in algebra terms, but I still have to do the exact same process. Blue plus purple equals green. So I'm going to take the blue, I'm going to add it to the purple, I'm going to set it equal to the green. 5x plus 1 plus 23 equals 7x plus 4. And if you can't see where I pulled things from, that was the purple, this is the green, and that's the blue. Okay, so that's where the equation came from. Now I'm going to combine my like terms. 5x plus 24 equals 7x plus 4. Move the smaller variable right to left. Left to right. The right needs to give something back. 20 equals 2x, so x equals 2. All right, it wants the blue one, which was this, 5 times 2 plus 1 equals 11. X is not 2, X is 10. Oh my goodness. See, no one's here to fact check me. It seemed way too small. That's what I get. Alright, X is 10. Still want the blue though. The blue is this. 5 times 10 plus 1, that's 51. And the green was this. That is 7 times 10 plus 4, 74. Okay. Again, we can check our answer here because we know blue plus purple should be green. I knew the blue because I just figured it out. It was 51. I had to do the algebra for that bit. But I also could have just gone up to the problem and say, hey, it told me that the purple part was already 23. Yeah, it would have told me that all of it together, the green, would be 74. So you don't have to do the algebra all the time, as long as you understand what's going on. Okay. JKM. MLKL. And JKL. Whole thing. Alright. Same bit. Green plus blue plus purple. So let's add these together right now. 8x, 43, take away 20. You're left with 23. And that equals 10x minus 11. Remove the smaller variable. Give something back. 34 equals 2x, x equals 17. I got it right that time, good for me. Okay, I plug it into the blue now. 8 times 17 minus 20. That's gonna be 136, 116. And then JKL, that is going to be 10 times 17 minus 11, or 159. Okay. Again, we could check to see if the whole thing is 159, we take away the 43, we should be left with that. It's true, it works. DEF is a straight angle, so that means DEF is worth 180. Highlight the rest of it. DEG. This one. GEF. Okay. Green plus blue equals purple. So add all of our stuff together, set it equal to 180. 23 x's plus 12 more is 35 x's. Minus 3 plus 8 is still plus 5, and that equals 180. If we subtract 5 from both sides, we divide by 35, we should get 5. Plug it in one at a time. DEG is the green. 23 times 5 minus 3 equals 112. Times 5 plus 8 equals 68. And both of these added together should be 180, but we also knew at the beginning that this DEF was 180. All right, hopefully there are enough examples here to help you put together the rest of it. If you need help, let me know.